As we saw in some of the earlier lectures, it's possible to get really complex and complicated when talking about how to analyze the EEG, especially if you're trying to do source modeling and source localization. However, from a practical point of view, a lot of really good studies can be done without the necessity of that level of analysis. And so in this lecture, or series of lectures, because there are more than one part, we're going to talk about some of the basic EEG parameters or features that have been used widely in the literature. In fact, when you look in the published literature, you find that more often than not, when people are studying a disease state or some kind of comparison among groups, these are the kinds of measures that you see in the literature. So without further comment, let's just talk about what some of these are. So before we discuss the actual measures, let's go back and review the EEG frequency bands. And most of the time, as people calculate these parameters, they're always done in reference to these frequency bands. And I'm sure you've seen this before, but we'll just review. The delta band is the lowest frequency band. It corresponds to non-REM sleep, and it's often seen in babies and very younger children. Theta band is when your brain is sort of on idle. A lot of press has been given recently to theta waves showing up in people who meditate. So it's kind of known as the meditation wave or deep relaxation wave. Alpha waves show up when you're relaxed but focused. So here you would be not meditating, but concentrating or thinking about something, but with eyes closed. So when your eyes are closed, alpha is the dominant adult waking wave, and you can see its frequency ranges from 8 to 12 hertz. There's a subband within alpha, usually found around 10 hertz, sometimes as high as 12 hertz. That has to do with motor movement and even imagining motor movement. This particular band is used widely in brain-computer interface technology, where people are asked to visualize a certain movement. That particular rhythm goes way up in magnitude. Beta waves are what we normally see when we do some kind of task-oriented EEG. So here you would be alert, you would be busy, you would be focused on some task, your eyes would be open, and the frequency range is rather broad, from 12 to 30 hertz. Some people do divide beta into two subbands. How it's divided, and even the entire beta frequency range is not consistent throughout the literature, and you will see some places where beta is defined from 12 to 24, from 12 to 22, and in this case in our table we have it from 12 to 30. So just keep in mind that that upper number is somewhat dependent on what resource you're looking at. And then finally, gamma. And gamma, for many years people ignored gamma because clinically it doesn't really yield a lot of information. It's higher frequency. It can't be really visibly discerned by the technician or the clinician who's looking at just raw EEG data. But there's been renewed interest in gamma. Gamma's thought to have to do with higher order thought processes and emotion, and then the interplay between thought and emotion. So, and there are some other things that people have postulated gamma waves do or present under certain conditions. So probably much more research to be done on gamma waves and how they show up in different disease states and different cognitive states. So those are the general EEG frequency bands. So as we go through and talk about different features, that people tend to calculate for the EEG will refer back to these EEG frequency bands. So let me just go to the next slide and let's look at an overview. This is by no means an extensive list or a complete list, but it is a list of some common parameters that show up in the literature for the EEG. And we'll go over each one of these, or most of them anyway, in detail. And there are also some very relevant publications that compare the effectiveness of these at looking at different things. So typically, let me just say, before we go into each individual parameter, typically what is done is the parameter, let's take average power as an example. So the parameter average power, and I'm sorry, my table's a little bit off, so here's the actual equation for average power, off by a line or so, but typically average power is calculated within the frequency bands that were shown on the previous page, usually at least the first four. So you would have 4 bands in which you calculate average power. And it's also typically calculated for every probe location. So what that means is on a 64-channel EEG system, you would have 64 channels and you would have 4 average power numbers per channel because you have 4 frequency bands. So that means you're dealing with 256 numbers. So you can begin to appreciate the challenge in evaluating EEG data if you're going to try to do any kind of pattern recognition or identification of features. You can see that you're just going to be working with a huge amount of data, and so lots and lots of channels of data, lots and lots of numbers that you then have to have some scheme for reducing. So in the next part of the lecture, we'll begin to talk about each of these features individually and define what is some of the relevance of calculating that feature, what information does it give you, and what does it mean, and how is it calculated.